It is feasible to load lighting fixtures onto an uninterruptible power supply, or UPS. However, several crucial factors merit careful consideration to ensure optimal performance, safety, and longevity of both the UPS and the connected lighting. Firstly, it is important to consider the total wattage of the lighting fixtures. Begin by meticulously calculating the aggregate wattage of all lighting fixtures intended for connection to the UPS. This total must remain within the UPS capacity, specified as 6 kVA in this scenario. Secondly, examine the power factor. Lighting fixtures often exhibit a power factor of less than 1. This characteristic implies that the actual power consumption surpasses the apparent power, or wattage. Accurate load assessment necessitates factoring in the power factor. Thirdly, evaluate the surge current. The inrush of current, or surge current, that occurs upon activation of lighting fixtures can significantly exceed the steady-state current. An improperly sized UPS risks overload from this surge. Fourthly, the battery backup time needs to be determined. The duration for which the UPS can sustain power during outages hinges on both the total load imposed and the battery's capacity. An excessive number of lighting fixtures can curtail the battery backup time. The following guidelines facilitate the safe and effective integration of lighting fixtures with the UPS. 1. Compute the total wattage. Sum the individual wattage ratings of all lighting fixtures slated for UPS connection. 2. Multiply by the power factor. Multiplying the total wattage by the power factor yields the actual power draw of the fixtures. 3. Incorporate a safety margin. Augment the actual power draw by 20 to 30%. This buffer accommodates surge currents and unforeseen variables. 4. Compare against the UPS capacity. Ascertain that the adjusted power draw remains at or below the UPS capacity. Consider an illustration. A lighting setup totaling 1000 watts with a power factor of 0.8 results in an actual power draw of 1000 watts multiplied by 0.8, which equals 800 watts. Applying a 20% safety margin results in 800 watts multiplied by 1.2, which equals 960 watts. Thus, these lighting fixtures are suitable for operation with a 6 kVA UPS without inducing overload. Always consult the manufacturer's documentation for your specific UPS and lighting fixtures. These resources offer invaluable insights into compatibility and safe operational practices. Remember to consider the type of lighting fixtures. Different types of lighting fixtures have different power requirements and surge characteristics. For example, incandescent bulbs typically have a higher surge current than LED bulbs. Also, you must consider the UPS topology. There are 3 main types of UPS topologies: standby, line interactive, and online double conversion. Each topology has its own advantages and disadvantages in terms of performance, reliability, and cost. If you are using a standby UPS, it is important to choose lighting fixtures that have a low surge current. Standby UPS typically have a lower surge capacity than line interactive or online double conversion UPS. If you are using a line interactive UPS, it is important to choose lighting fixtures that have a power factor close to 1. Line interactive UPS can correct for power factor, but they are not as effective at correcting for power factor as online double conversion UPS. If you are using an online double conversion UPS, you can use any type of lighting fixture. Online double conversion UPS provide the best protection against power problems, but they are also the most expensive. Always follow local electrical codes and regulations when installing and using a UPS. Improper installation or use of a UPS can be dangerous and can void the warranty. Here are some additional tips for loading lighting fixtures on a UPS. Firstly, use energy-efficient lighting fixtures. Energy-efficient lighting fixtures will reduce the total load in the UPS and extend the battery backup time. Secondly, use a UPS that is sized appropriately for the load. A UPS that is too small will not be able to provide enough power to the lighting fixtures, and a UPS that is too large will be more expensive than necessary. Thirdly, test the UPS regularly. Test the UPS regularly to make sure that it is working properly. This will help you identify any problems before they cause a power outage. Lastly, consider the inrush current of the lighting fixtures. This is the amount of current that the lighting fixtures draw when they are first turned on. The inrush current can be several times higher than the steady-state current, so it is important to choose a UPS that can handle the inrush current. Another important factor to consider is the harmonic distortion produced by the lighting fixtures. Harmonic distortion is a type of electrical noise that can interfere with the operation of other electronic devices. Some types of lighting fixtures, such as compact fluorescent lamps or CFL, and LED lamps can produce significant amounts of harmonic distortion. If you are using these types of lighting fixtures, it is important to choose a UPS that is designed to filter out harmonic distortion. Some UPS have built-in harmonic filters, while others require an external harmonic filter. You should also consider the environmental conditions in which the UPS will be operating. If the UPS will be operating in a dusty or humid environment, it is important to choose a UPS that is designed to withstand these conditions. Some UPS are sealed to protect them from dust and moisture. Also, consider the altitude at which the UPS will be operating. UPS are typically rated for operation at sea level. If you will be operating the UPS at a high altitude, you may need to direct the UPS capacity. Consult the manufacturer's instructions for more information. Finally, it is important to have a qualified electrician install the UPS. A qualified electrician can ensure that the UPS is installed properly and that it meets all applicable electrical codes and regulations. It is also important to have a maintenance plan for the UPS. A maintenance plan will help to ensure that the UPS is operating properly and that it will provide reliable power protection for your lighting fixtures. The maintenance plan should include regular inspections, testing, and battery replacement. The frequency of the inspections, testing, and battery replacement will depend on the type of UPS and the operating conditions. In addition to the above factors, it is also important to consider the following. Firstly, the type of lighting fixtures you are using. Some lighting fixtures, such as fluorescent lights, require a higher starting current than others. Secondly, the number of lighting fixtures you are connecting to the UPS. The more lighting fixtures you connect to the UPS, the more power it will need to supply. Thirdly, the length of time you want the lighting fixtures to be powered by the UPS. The longer you want the lighting fixtures to be powered by the UPS, the more battery capacity it will need. Once you have considered all of these factors, you can calculate the total power requirements of your lighting fixtures. Then you can choose a UPS that is large enough to meet those power requirements. It is always better to choose a UPS that is slightly larger than you need, just in case you add more lighting fixtures in the future. Also, be sure to check the UPS specifications to make sure that it is compatible with the type of lighting fixtures you are using. Some UPS are not compatible with certain types of lighting fixtures, such as fluorescent lights with electronic ballasts. Finally, it is important to follow all of the manufacturer's instructions when installing and using the UPS. This will help to ensure that the UPS is installed correctly and that it is operating safely. Here's a breakdown of how to approach this systematically. Firstly, identify all the lighting fixtures you intend to connect to the UPS. List each fixture individually. Secondly, for each fixture, determine its wattage rating. This information is typically printed on the fixture itself or on the bulb. Thirdly, note the power factor of each lighting fixture. This may also be printed on the fixture or bulb. If it's not available, assume a power factor of 0.8 for fluorescent lights and 0.9 or higher for LED lights. Fourthly, calculate the volt amps, or watt, for each fixture by dividing the wattage by the power factor, that is VA equals watts divided by power factor. Fifthly, sum the volt amps of all the lighting fixtures to get the total volt amps load. Sixthly, add a safety margin. Multiply the total volt amps load by 1.25 to add a 25% safety margin for potential surge currents and future expansion. Seventhly, compare the total volt amps with the UPS capacity. The total volt amps, including the safety margin, should be less than or equal to the UPS capacity, which is 6 kV amps. Eighthly, consider the battery runtime. Estimate how long you need the UPS to power the lighting fixtures during a power outage. The battery runtime depends on the load and the battery capacity of the UPS. Ninthly, consult the UPS documentation. Refer to the UPS manufacturer's specifications for the maximum load capacity and battery runtime at different load levels. Tenthly, test the setup. After connecting the lighting fixtures to the UPS, test the system by simulating a power outage. Monitor the UPS load level and battery runtime to ensure that it meets your requirements. And finally, consider a staged approach. If the total load exceeds the UPS capacity, consider connecting only essential lighting fixtures to the UPS and leaving non-essential fixtures on the main power supply. By following these steps, you can safely and effectively load lighting fixtures on your 6 kV amps UPS and ensure reliable power during outages. Additionally, remember that the surge current is a momentary spike, but it can still trip the UPS over load protection. To mitigate this, consider using soft start lighting fixtures or installing a soft start device on the circuit. Soft start devices gradually increase the voltage to the lighting fixtures, reducing the inrush current. Furthermore, keep in mind that the UPS is designed to provide temporary power during outages. It is not intended to be used as a continuous power source for lighting fixtures. Prolonged use of the UPS at its maximum capacity can shorten its lifespan and reduce its reliability. Finally, regularly inspect the UPS batteries for signs of damage or deterioration. Replace the batteries as needed to ensure optimal performance.